In this video, we will explore adding and subtracting fractions. Let's start with a relatively easy problem, like 1/4 plus 1/2. We want to add that up. Now, the reason people make so many mistakes when adding fractions is they're really not visualizing what they're doing when they're adding fractions. You're not just moving numbers around. So let me first of all list some of the common mistakes, things that people do that go wrong. Common mistakes. Probably the first common mistake is that people say, since we're adding, let's just add up the numerator and the denominator. So if you did that, you would say 1 plus 1, adding the numerator, gives me 2. 4 plus 2 in the denominator gives me 6. That is wrong. So notice these are common mistakes. These are the things not to do. Another common thing is to say, when we're multiplying fractions, we know we do different things, but people forget when they're adding and when they're subtracting. So you might say, well, let's multiply the numbers in the numerator and get 1, and then let's multiply the numbers in the denominator and get 8. Now let's visualize the problem and see why the common mistakes are so egregiously bad. So rather than thinking abstractly in terms of numbers, let's pretend we're in the kitchen. Let's pretend we have cups. And let's say that one of them is 1/4 of the way filled with liquid. So to get a quarter, I'm going to make little dividing lines. So this bottom quarter of the cup is filled up with liquid. The top 3/4 of the cup are empty. For the other cup, it's divided in half. And we have half a cup of liquid and half a cup that's empty. Now let's get one more cup out of the cupboard here. Let's assume we've got a nice matching set despite my drawings. And let's pour cup number 1 and cup number 2 into our new cup and see what happens. Well, we know that, let's pour the second cup in first to make it easy. We'll have that much in there. And then we pour the second cup on top, and miraculously the layers don't mix. So it looks like this. I think you know what the answer to the problem is, but let's explore why this picture shows that the common mistakes are so bad. So first of all, 2/6. Hopefully you know enough about fractions at this point to realize that would be the same as a 1:3 ratio. If we divide both the numerator and the denominator by 2, 2/6 would be the same as 1/3. So we had seen in a previous video that if we do the same thing to the numerator and denominator, so if we were to multiply by 1/2 over 1/2, that would be the same as multiplying by 1. And that's the added multiplicative identity, and we would get 1/3. Clearly, what we have after we combine the two cups is not 1/3 of a cup. The second answer is far worse. 1/8 is even less, and we clearly have much more than half of a cup. In fact, when you're adding things, the result, the sum, if you have two positive things, which in this case we can only add positive amounts of water, if you add two positive things, you have to have an answer that's bigger than the largest thing that you had to begin with. So we have to have an answer that's bigger than 1/2. Neither of the two answers in our common mistakes came out to be bigger than 1/2. Obviously, adding a quarter to a half will make it even larger. Now, in this case, I think you know what we need to do to make the math easy. If our half cup had been subdivided down, we could have an imaginary amount of water in the bottom that would be equal to 1/4 of a cup. And then above that imaginary line, we would have another 1/4 of a cup, and we have 1/4 of a cup over here. So another name for half would be 2/4. So we could rewrite the problem that we have 1/4 plus instead of 1/2, what I'm really doing up here is I am using my multiplicative identity, and I'm multiplying by 2 over 2, which is just 1. When I do that, I get that I have 2/4. Okay? It's probably better to think of that as we have 1/4 cup plus 2/4 cups, and the end result is that we must have 3/4 cups of liquid, also written as 3/4 of a cup of liquid. So you can put the dividing lines in right here and see how the quarter cups add up, and we've got a quarter, and another quarter. But up here at the top, we have 1/4 that did not get filled in. So we have 3 of the quarters filled in by the time we add those cups together. Okay, so what did we do? You may have heard when you're talking about adding fractions that to add them, you need to have a common denominator. What this is really saying is we need to add things that are like each other. The only thing like a quarter cup is another quarter cup. So we can add up quarters of cups. We can't add half cups and quarter cups together and make any kind of sense of the numbers without running into our common mistakes. So let's try another problem. Okay, let's try 1/3 plus 1/2. This one's slightly trickier than the one we just had. So let's go back to the cupboard and make visual sense of all of this. My cups aren't quite the same, but we'll just pretend they are. So 1/3 would mean that we fill this one up that far, and there are these 2 other thirds that are empty. The second one is halfway full, like this, and the top half is empty. Okay, now let's combine them together. Maybe I'll do this down here. We pour the 2 cups into one, and let's start by pouring the bigger one in first. So we fill this one halfway, and then when we take the second one, we end up filling it not quite as much as the first cup did, and so we have a half, and we have a third. Now, what is that going to give us? Well, we need to do what we did before. We have to get a common unit of measure. Well, the best way to do this, if we're dealing with numbers like a third and a half, is to take the third and divide it in half one more time. And then each of the thirds will be divided in half. And if you count them up, you can see we have 1, 2, 3, 4, 5, 6 units of 6 individual units, okay? Or we've divided it into 6 parts, all right? And you can see that 2 of those parts are filled. So what we can do is we can rewrite a third. We could technically use the multiplicative identity. Let me do it over here. And if I multiply this by 2 over 2, the first part of the fraction becomes 2 out of 6. Now let's do a similar thing to our half, okay? The difference is we want the same size units that we had before. So what we need to do is we have to get this one divided into 6 parts. So to do that, if we put our lines in evenly, you can see we now have 1, 2, 3, 4, 5, 6. Oh, and 3 of the 6 are filled. Well, arithmetically, what we can do is we can multiply this by the multiplicative identity using 3 over 3, and we can say that 1/2 is really the same as 3/6. Now we have 2/6 plus 3/6, and if you have 2/6 and 3/6, it's clearly going to be 5/6. Now let's consider what would happen if you subtracted 1/3 from 1/2. Just on the side here, if I had, let's actually reverse that just to keep with positive answers. If I were to subtract 1/3 from 1/2, we could rewrite the 1/2 just like we did before as 3/6, and we would take away 2 out of 6. So if we had 3 1/6 and we take away 2 1/6, we should be left with 1 1/6. And we never write 1 1/6, we just write 1/6 as our answer. Let's try one more. Let's do the following. Let's do 3/5 plus 1/2. Before we start cranking out an answer, let's visualize this. So once again, let's get our cups out. So I have a cup and another cup that looks a little skinnier, but just ignore that. Okay, and let's get our water out. And we need 5 parts. So let's see, 1, 2, 3, 4, 5. Okay, so we have 3/5 that are filled. Notice where my little hash marks are. And notice 3/5 is, probably didn't put it quite high enough. I'm going to put it up right about there. So 3/5 are filled, leaving 2/5 empty. And in the other one, 1/2 is filled. Okay, now it's clear because the first one is a little bit bigger than 1/2. When we dump our cups together, so I'm going to combine them down here. If I get another cup out, if I put the 1/2 in first, and then try to put the 3/5, it's going to be over the top. So what can we do? We can finish filling this one with another 1/2, but it's pretty clear, I think, since we had more than a 1/2 in the first cup, that there's going to be a little bit left over in the bottom. And we need to be able to figure out what that is. Now, what does our cup analogy help us to do? Our cup analogy tells us a couple of things. First of all, we can already know that our answer has to be more than 1 cup. So the answer must be greater than 1, but probably only a little bit bigger than 1, not a lot bigger than 1. So by knowing that going into the problem and doing the arithmetic, we can probably save ourselves from making mistakes. All right, now you may notice that 2 and 5, okay, we've divided into fifths and we've divided into halves. Well, we need to figure out something that would work so that we can have the same units for both. And here's where we need to get the least common denominator. We need to think about multiples of both of these, okay? So if I start with the number 5, you could have 1 times 5, or 2 times 5, or 3 times 5, or 4 times 5, and so on. If you start with the number 2, you could have 1 of them, 2 times 2, and let me just write them out, 6, 8, 10, 12, and so on. And you will notice both of them have 10 as a multiple. For 5, it's 2 times 5. 2 times, and for 2, it is 5 times 2. So what is 10 called? It's called the LCM, or least common multiple. Now keep track, this was 2 times 5, and it was 5 times 2. So what do we do to the problem? Well, let's rewrite it. Let's write 3/5, but let's then use the multiplicative identity and multiply it by 2 over 2. Then let's take 1/2 and use the multiplicative identity and multiply it times 5 over 5. Notice the 2, because 10 was the second multiple of 5, and the 5 because 10 was the 5th multiple of 2. So now we can continue the problem, okay, and we're going to talk about multiplying fractions in the next video. But to multiply these together, you're going to end up with 6 out of 10. You multiply the numbers in the numerator together, and you multiply the numbers in the denominator together. So we have 6/10 is the same as 3/5. And when we multiply the numbers in the numerator together in the second term, we get 5 over 10. So 3/5 was the same as 6/10. 1/2 was the same as 5/10. We're now speaking the same language. We have 6/10 plus 5/10. And clearly when you have 6 of something and you add 5 of it, you end up with 11 of whatever it was. So in this case, we have 11/10. So what is our answer? It's 11/10. If you want to write that as a mixed number, it's 1 and 1/10. Okay, the 1 represents the filled cup, and the 1/10 represents the little bit extra that's spilled over.